So welcome to this. This is the Further Maths Support Programme online revision session for Edexcel S1. And in this session we're going to be combining and looking together at correlation and regression. These topics are very linked together, so it makes sense to look at them together because most of the exam questions cover both aspects at the same time. So for correlation we need to be able to calculate this thing called the product moment correlation coefficient, which is given to you in the formula booklet, as are its constituent parts to find. You need to be able to state what the PMCC is saying. In other words, you need to be able to interpret it. And also, you're expected to use a little bit of coding to find information about PMCC and also about the related variances that link with that. Moving on to regression, you need to be able to calculate the least squares regression line y on x. Now in theory they could ask you the regression line x on y, and you've just got to be really careful, and I'm going to try and help you make sure that is not ever going to be an issue. You also need to be able to tell me what the gradient means in context, and also what the y-intercept means in context. And likewise you need to be able to use coding while dealing with regression. So as always, it's a good starting point is to go into questions. So a farmer collected data on the annual rainfall x and the annual yield of peas p per acre, and we're given some data in terms of SVV, SPV and so on, and we're told that V is equal to x minus 5 over 10. It has already been coded. Now they've been very nice in this question because they've asked for the least squares. Well, they've asked for the equation of the regression line P on V. Now you need to recognize that means that P is the subject of your equation. It is the thing that is going to go on the y-axis. Okay, and they've really nicely told you this here. Now some observations to make before we crack on with this question, and this is the point about rounding. Please make sure that first of all you're writing down things to 3 significant figures or better throughout. But more importantly, that you are not using rounded answers going through a question. Okay, that's going to be really important. Right, so we're asked to find the regression line. So the first thing we need is the equation for the gradient b. So we're told that the regression line in the formula booklet is y is equal to a plus bx, where b is equal to s yx on sxx or sxy. Depends how you've been shown it in your notes. Okay, now of course in this particular question we've got p's and v's, not x's and y's. So we do recommend quite strongly that you do put it into context. So we should be using SPV divided by, now you need to make sure that you've got your x variable correct. In this particular question the x variable will be v, so it's going to be on SVV, which is great because we've got all of that information. So b is going to equal SPV, so 1.688 divided by SVV, which is going to be 5.753. Calculating those is going to give you 0.293. It goes on in your formula booklet to tell you that y bar is equal to a plus bx bar, and it writes in the formula booklet that a is equal to y bar minus bx bar. So in this case, again, we've just got to make sure that we're using the correct letters. So we're dealing with p bar minus b v bar. So that's what the value of a would be. So a is equal to p bar, so 3.22 minus b, and again you should be using not the rounded value but the calculated value while you do this. So just be really aware of that. Times by v bar, which is 4.42, and upon calculation of that, that's going to give you 1.92, and there's going to be more decimals. So now to write the equation of the line, it's going to be p is equal to a plus b v. Okay, so that's going to be plus 0.293 v. So again, answers do get written to 3 significant figures, but you should use the exact value throughout. Where your marks are indicated are as follows. You get 1 mark for ensuring that the fraction for b is the correct way round, and then of course a for accuracy, and likewise you get 1 mark for using the correct formula for a, and then a mark for accuracy. it goes on and says, using your regression line, estimate the annual yield of peas per acre when the annual rainfall is 85 centimeters. So we need to realize that they're really talking about the variable p and the variable x. Okay, so you've got your regression line, which is p is equal to 1.92 plus 0.293v, and you need to realize that actually we want to be finding p when we're given the value of x. So what we should be doing is then realizing that v is equal to x minus 5 over 10. And it's that equation that we're going to be using, except that x in this particular case is 85. So calculating this through, p is equal to 1.92 plus 0.293 multiplied by 8 in total. 85 minus 5 over 10 is 8, which gives me a value of 4.3. And again, it's any answer which rounds to 4.3. Okay, so you get 1 method mark effectively for using the fact that we're supposed to be using 8. Again, there are other ways of doing this, but this is predominantly what we're looking for. And then an accuracy mark for getting p correct. Okay. So as I say, students lose marks here by not using the correct accuracy. That's the main principle with that. So this question is looking more at PMCC, product moment correlation coefficient, and we're given a mixture of information here. We're given SXX's, we're giving a sum of y squared, and an SXY. So they are testing in this question your ability to find and use equations to get SXX and so on. So on your formula sheet, you are given the fact that SYY is equal to the sum of y squared minus the sum of y squared over n. And this is where a lot of students go wrong with this particular question, because they do effectively the sum of y over n squared, and they square the whole thing rather than just the numerator. And this is by far the safest way of doing this type of question. Okay, so we've got the equation 4305 minus 181 squared divided by 8. And the reason we're dividing by 8 is because we're told that there are 8 in the sample. Okay, so calculating that is going to give me 209.875. And because of how the rounding works, we are allowed to have any answer that rounds to 210. So you'll see when you look at mark schemes, it'll say things like 210 and then AWRT, just so you're aware about how to interpret those. Okay, so then it's asking us to calculate the PMCC, the product moment correlation coefficient, which is symboled as R. So that's going to be S of xy divided by the square root of SXX SYY. And again, you've got to be very, very careful using this. So SXY is minus 23726.25 divided by the square root of what we've just calculated. So we're going to use SXX, which is 3535237.5 multiplied by 209.875. Okay, so again, you should be using as exact a number as you can as we go through. Okay, and if we calculate that, we're going to get minus 0.871. So just a few things to note while we're here. There are 2 marks for this. Method mark for putting the right numbers in the right place in the formula, and then of course an accuracy mark for getting the correct answer. Just looking at the answer to this, it's negative, so we can see that it's a negative correlation, and it's quite a strong negative correlation as well, because it's 0.871. Now, for part C, it's definitely asking for an interpretation of the coefficient. So you do need to go all the way back to the context. I'm going to do it up here. You need to go all the way back to the context to make sure you're answering this correctly. So you need to make sure that you know your variables. Okay, that's really, really important. So here we can see that one of the variables, the x value, is the height above sea level. and the Y one is the midday temperature. So they are your variables, and if we're going to use them, we must make sure we use exactly as it's written. So what we can interpret this as is the higher above sea level a town is, okay, so the higher above sea level a town is, we can then comment the cooler the temperature, because it's a negative correlation. Okay, so anything like that will do just fine. But it's the fact that we really do. I mean, you could argue we should be using the midday temperature, and that would be perfect. So the cooler the midday temperature would be ideal, but that was allowed on the mark scheme. Okay, so the question continues. A student thought that the calculations would be simpler if we decided to do it in kilometers instead of meters, and we're asked to write down the value of SHH. Now, this is a particularly tricky question because you just need to know how this works. So when you're coding, what you need to realize is you're applying the coding twice. So in other words, SHH is equivalent to SXX divided by applying the coding in a square way. And the reason we do this is SHH is really linked to variance. Okay, so when you look at discrete random variables, you see this sort of statement. And that's effectively true for all of these SHHs and SXXs and things. So if you code these summatives, then they have the same behavior as variance. Okay, so when it says write down, you're dividing by a million, so this should be 3.5352,375. However, for part E, the correlation coefficient is still minus 0.871, and that's because all you're fundamentally doing is changing the axes. The relationship between the points is still the same. So PMCC is what we say invariant under coding. Okay, so that's quite a tricky question actually. So here's another one. We've got a random sample of 50 salmon caught by scientists. He records the length and the weight of each salmon. So your brain should instantly be dealing with L's and W's. That's really important. So we're asked to find SLL and SLW. So again, SLL will equal the sum of L squared minus the sum of L squared over N. So to complete this calculation, that's going to give me 327,754.5 minus 4027 squared over 50, and that's because we've got 50 salmon, and calculating that will give me 3419.92. So a method mark and an accuracy mark for getting that far. Then to find SLW, just a little bit of a heads up, that's the same as SWL, the symmetry here. So this is going to be the sum of LW minus the sum of L sum of W over N. If we calculate that, that's going to be 29330.5 minus the sum of L, 4027, times by the sum of W, 357.1, all divided by 50. And again, carefully typing that into your calculator will give you a value of 569.666. And you get only one more mark for that because fundamentally it's the same skill. So, they're not going to reward you heavily for that. And then part B is to calculate PMCC. So we do that in pretty much the same way, and then we can interpret it in pretty much the same way. So it's quite a similar question, other than, as I say, you have to work out your summatives in more of a detail. So R in this case will be SWL over the square root of SWW. Notice I am not using X's and Y's, and it's really important that you get into that habit. So 569.99666 divided by the square root of SWW, which is given 289.6 times by 3419.92. Okay, and that's going to give me 0.572. And depending on how you round it, and if you've been rounding values throughout, we would also accept in this question 0.573. So the interpretation, again, is trying to link it to the question. So we're looking at the length and the weight of salmon. So you can say as the length of salmon increases, so as the length of salmon increases, so does its weight, or words to that effect. Okay, so the other things you need to be aware of is you need to remember how to interpret the gradient of a line of best fit and also the y-intercept. So the gradient is per unit in the x direction, how is your y variable changing?